Alright, so today we are focusing our discussion and starting the discussion of linear functions. And so, of course, linear function we discussed in our function families before. We kind of know the basics about them. You can go back to those notes to kind of review things like domain and range and x-intercepts, y-intercepts, those kind of details that are specific to linear functions. So we're going to start today talking about the slope and that rate of change of a linear function and kind of continue our discussion from there. So first off, a rate of change is, of course, a ratio that shows how one variable changes with respect to another. So in a linear graph, we call this the slope of the line, okay? But it's always going to be rate of change no matter which function we're talking about. So slope is written, of course, as a ratio of the vertical change, that's going to be our rise, and the horizontal change, which is our run, between any 2 points on the line. And because slope for a linear function is constant, it's going to be any 2 points on the same line. Now, if it were a non-constant slope, if it were a different type of function, like for example an exponential function that's not got a constant slope, we would have to find an average rate of change, and we'll learn about that when we get to those function types. But for now, we're learning about linear functions, which are constant rate of change, so it's going to be any 2 points on the same line. So slope is written as a fraction in simplest form, and the variable that we use is m. Okay. Well, there's a few different types of slope. So this is a positive slope. Negative slope goes down. Zero slope is a horizontal line, and a vertical line is an undefined slope. Okay. Alright, so to find the slope on a graph, if we were just looking at the graph itself, we're going to use rise over run. So for example, in this number 1, we have this point right here and this point right here. So the first thing we're going to do is going to count the rise. 1, 2, 3, 4, 5, 6, 7. And then we're going to count the run. 1, 2, 3, 4. So we're moving in a positive direction. Okay, remember positive is moving upwards on a vertical axis. And then positive direction again with the horizontal axis, so 4. So our slope here is 7 over 4. Okay. Another example here on number 3. So we have this point here and this point here. So the rise is 0. I'm not going up any. The run is 1, 2, 3, 4. And so I end up with a slope of 0. Okay. And then just like we said, a horizontal line has a slope of 0. Okay. Couple more examples. Let's look at number 5. So 5 here, we have a point here and a point here. So rise, 1, 2, 3, 4, 5. Run, 1, 2, 3. And so we have a slope of 5/3. Number 7, same process. Here we're going to rise, 1, 2, 3, 4. We're going to run, 1, 2. And this simplifies to be 2 as our slope. Okay, then we have number 9 down here. Now notice here, when we rise, we're actually going to be going down. So that's going to be a -3 and a run of 1, 2, 3, 4, positive 4. So we end up with a -3/4 slope. Okay. On number 11, here we're going from this point to this point. So of course, rise, there is 1, 2, 3. Run, there is 0, and we can't divide by 0. That's where it becomes undefined. Okay, if you try to put that in your calculator, you will get an error message. We don't ever divide by 0. So that's where the undefined comes from. Vertical lines are undefined. Okay, here we have a rise of 1, run of 4. So we have a slope of 1/4. And then here we have a rise of 2 and a run of 6, which reduces to 1/3, simplifies. So 1/3 is going to be our slope here. So you'll notice here when our arrow is pointing, or our line is moving downwards, that's going to be a negative slope. Here it's a positive slope because it's moving upward, undefined for that vertical line. And then of course our horizontal line down here is a slope of 0. Okay, so that's kind of the basics of how slope and rate of change is going to work for a linear function.